students, welcome to the chemistry sessions. So I hope you all have revised the concepts for hydrocarbons. So we are going to deal with the JEE main pattern exercise today. So let's start the questionnaire round. So the question 1 says what? Now, the major organic compound formed by the reaction of 1,1,1-trichloroethane with silver powder. So actually what kind of a reaction is it? Just try to recall. They are utilizing the silver powder. That means what? Trichloroethane. So let us just make it. That is trichloroethane. So you must have an idea about a reaction which is between chloroform and silver. So here we take 2 moles of chloroform, something like this. This is what we are taking, that means 2 moles of chloroform giving what? It is a reduction reaction. So basically it forms 3 moles of AgCl along with alkyne. So here there is the formation of alkyne, acetylene and 3 AgCl. So I need to have 6 moles of Ag. So that is what it is needed in this very particular reaction that has been given. So I need to find out the major organic product, major compound which is getting formed, acetylene, ethene, 2-butyne and 2-butene. So let us just have the product. I am using again 6 Ag, Cl3C, CH. So that is what we need over here, CH3. And again similar sort of reaction that we have done over here. What do we get? We get triple bond, again an alkyne, but this time what kind of an alkyne? It's but2-ine. That is what we are getting here. 1, 2, 3, 4. That means but2-ine. That is what we are getting, plus 3 AgCl. Okay, let me just make it 6 over here. In total we are getting 6 AgCl. So that is the complete reaction what we are getting. So let us just try to match our answers. So acetylene, it is not the product. Ethene, again not the product. But2-ine, but2-ene. So we have got ine, that means we have got an alkyne. C is the correct option. I hope everybody has followed the reaction. So let's just move on to the next question. What do we have? Again a pretty simple question, but it requires proper use of reagents. So I have got compound A. What is the compound A? C8H9Br. So you do not have to guess what compound is it. It actually involves any of these compounds. It actually has an aromatic ring that is definite, gives a white precipitate when warmed with alcoholic AgNO3. So whenever we have got a bromo compound and it reacts with AgNO3, so we are not getting white precipitate here, it may be a misprint. So we get sort of a light yellow kind of a precipitate we get whenever there is the reaction. Oxidation of A, we have got the A, that is the compound I need to choose, gives an acid. What is the acid over here? Such kind of an acid. So we are not given the structure of the acid yet. Then it easily forms, that particular acid easily forms an anhydride on heating. So which kind of an acid do you know which is aromatic also, and on heating it gives up anhydride? What kind of acids give anhydride? Carboxylic acids. And we need to have what? We need to have 2 carboxylic groups in order to form an anhydride. So that is for sure. So what would be the answer over here? Let us just have a hit and trial method over here and try to guess the answer. So it would be if I would have got phthalic acid as the answer, so upon heating phthalic acid, so I hope everybody has guessed it out. What do we get? We get anhydride, that is the phthalic anhydride. So that is what we are getting. So this is phthalic anhydride. Let us just check it that whether we are getting C8H6O4 or not. So is it? It's 6 carbon atoms, 7, 8. 8 carbon atoms confirmed. H6, is it H6? 1, 2, 3, 4, 5 and 6? Yes, definitely. We have confirmed C8, H6. And what about O4? Definitely we are getting 4 oxygens here, and we have confirmed the compound B. Now let's have the structure of the previous compound, that is A. So it is for sure that upon oxidation we get oxidation of A. We get what? We get this very compound, that is phthalic acid. That means it must be having the compound A which is initially taken, it must be having ortho positions. That means let us just select out of all. So out of all, you can see over here that there is number 1 and number 2. That means B and D could be our possibilities. So if you look upon the reaction, number 1 reaction will give our answer, the main answer. So the compound C8H9Br gives a precipitate. We are just considering the precipitate when warmed with alcoholic AgNO3. So what is the particular reaction here? We get AgBr as the precipitate. And this very kind of a reaction happens only in straight chain, only in aliphatic aldehydes. So, sorry, not aliphatic aldehydes but aliphatic halogens. That means what? I will be considering this as option or not. This is the bromine which is directly attached with the aromatic ring. That means we do not need this. But what do we need is this, that a straight chain carbon atom is having the bromine. This particular compound will definitely give the reaction with AgNO3. So let us just have the reaction. What kind of products will be getting formed over here? So I am just rubbing this off. So the product will be here in this case. I need side chain substitutions in order to have this reaction. Otherwise, a reaction with AgNO3 directly with the bromine which is directly attached with the benzene ring is not possible. So here I am choosing the side chain substitution. So I hope everybody is following me. What do we get? AgNO3 in the presence of alcoholic AgNO3, that means alcohol I have taken, C2H5OH. What do we get as an answer? We get AgBr as the light yellow precipitate. CH2OR, or I can say OC2H5. What is this? So if you look upon here, this very group gets attached onto the CH2, and along with what do we get? AgBr as precipitate. So that is the reaction over here, and also we get HNO3 in the reaction mixture. So this is the precipitate that we get. And this reaction always happens in the side chain substitution and not directly attached group. So I hope that is very well clear to you. This particular reaction is very important. So what do we get as an answer? We get D as the answer, and I hope everybody has got it right. So let's just move on to the next one. What do we have? Okay, now a solution of L-chloro 1-phenylethane in toluene racemizes slowly in the presence of a small amount of SbCl5 due to the formation of. So basically you do not need to go into the detail of the reaction, but what you need to see is solution here. So let us just draw the diagram. It is 1-phenyl ethane, that means I need eth CH3, that is eth. It is 1-phenyl and okay, it would be 1-chloro. So it is something like this. So that is the compound that we have. Racemizes slowly in the presence of a small amount of SBl5 due to the formation. So we want to react it with SBl5. So let us just look at the concept over here quickly. Whenever there is some kind of a reaction which is having a carbon here, carbon which is a chiral carbon. What is a chiral carbon? A carbon which is attached with all the 4 groups different. Here I have got all 4 groups different, that means it is a chiral carbon, that is why I have marked it as star. So this is having a chiral carbon, that is a chiral compound. And what happens here? It racemizes slowly in the presence of small. What is racemizes? Creating a racemic mixture. So whenever you hear the word racemic mixture or racemization or racemizes, that means I will be getting my mid product as a carbocation. So here I will be getting a carbocation. Firstly, this chlorine will go off, that is the intermediate which is formed. And again this is what? This is a carbocation. So this very carbocation is now going to racemize. That means the attack of the chlorine can be on the either sides. It can be from the front side or it can be from the back side in order to have a product. So that is what our intermediate is. So that is a typical kind of a reaction. You need to have a proper hold. This very particular mechanism is involved within the optical isomerism. So you need to have a proper hold over that concept. So I hope everybody is getting me. The intermediate formed is what? Carbocation, due to which we get racemic mixture, or I can say it racemizes slowly to form some products. So that is what the reaction is saying. I hope everybody has got the idea. Let's now go on to the next question. What do I have? Okay, it's a very interesting question related to iodoform. Iodoform can be prepared from all except. Now what is iodoform? That is the iodoform. And what all compounds give this iodoform test? So here I have got iodoform test. And this iodoform test is actually given up by, the compounds like these very type of compounds or compounds having such groups. So these are the two particular compounds, or I can say groups, which need to be attached on a compound for that compound to give iodoform test. What is iodoform test? Whenever I make these compounds react with I2 in the presence of NaOH, I get yellow precipitate. What kind of a yellow precipitate? This kind of a color I will be getting, and it will be definitely corresponding to iodoform, the formation of iodoform. Iodoform which is formed in the reaction mixture is yellow in color. That is the precipitate that we get. And only these type of compounds will be giving this particular test. So let us just check what all compounds are given. I have got ethyl methyl ketone, that means ketone having ethyl and methyl on one side. So that is what we are getting. If you see over here, look very carefully, I have got this particular group over here, that means it will give the iodoform. If I go on to the isopropyl alcohol, what is isopropyl alcohol? It is this. This is isopropyl alcohol, and also if you see very carefully, I have again got the group over here. That means this will also give the iodoform test. What next? 3-methyl-2-butanone. So I have got but and 2-butanone and 3-methyl. So again, if you observe the compound, you will see again this particular group present over here. This will also give the test. But if you look on to the isobutyl alcohol, what is isobutyl alcohol? It is this. Okay. Now it is isobutyl alcohol here. So can you see such kind of a compound over here? I do not see any such kind of a compound over here. If you correlate the two structures, it is no way similar. So that means isobutyl alcohol will not give the iodoform except all. So I hope everybody has got the answer right. It is a very, very important test. It is repeated frequently. The questions have come up in the examination from this particular topic. So let's just move on to next. What is the next question? The non-aromatic compound among the following is. So how do we find out what non-aromatic compounds are? I need to check up for the Huckel's rule. So for non-aromatic compounds or aromaticity, I need to check up for Huckel's rule. So what does it say? It says it must be cyclic, it must be planar. Third is what? It must behave, it must be conjugated as well, and in respect to the conjugation, it must be having 4n plus 2 pi electrons. So that is what Huckel rule is saying. So let us just check quickly. If you see, all the compounds are cyclic, all the compounds are planar because there is no such kind of a compound. Yes, if you observe over here, what is the hybridization of this carbon? This is sp3. That means it is making this very particular compound non-planar. Also, there is no conjugation present in this compound. It must be double, single, double or anything in between in order to make it aromatic. That means this very compound is what? It is non-aromatic. We have got our answer. If you look here carefully, let us just analyze all the other options. Sulfur has got electrons. It will be involved in the 4n plus 2 pi system. That means if I put n equals 1, I get 6 pi electrons for this very particular compound 1, 2, 3, 4 and 5, 6. So that is how we are counting the electrons. I hope everybody is getting my point. So it will be following the Huckel's rule. It's cyclic, it's planar, it is conjugated, it is double, lone pairs, double. So that is how the conjugation is, and it is following up the 4n plus 2 pi system as well. Now let's move on to this very particular compound. What is this? We all know that is naphthalene. And naphthalene is always cyclic, it is always planar, it is always conjugated, and it has got fulfillment of the 4n plus 2 pi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means if I put n equals 2, what do we get? Here n equals 2, we get our answer. That means this is also aromatic. If you look here very carefully, again a similar kind of a case as in this one. So here again I have got 6 pi electrons, and it will be conjugated as well as it will be planar as well as a cyclic compound. So that means this is also aromatic. What is non-aromatic out of all four is this particular one. So I hope everybody has got my answer. So now let's just move on. What does the next question say? What do we have next? Now, okay, a very interesting reaction it is. 1 mole of a symmetrical alkene, first of all I have got a symmetrical alkene. That means it must be somewhat like this. That is what they are talking about. Alkene on ozonolysis. So that is the reaction that we need to perform. Give 2 moles of an aldehyde. So it will be giving twice of some RCHO, having molecular mass as 44U. So the molecular mass is 44U. Let us just hit and trial this. So if I put R as my methyl group, if I take up R as methyl group, what do I have? I have got CH3, CHO as the one aldehyde formed. That means what? If I look upon and try to calculate the molecular mass, I get 12 plus 12. That is 24 plus 16 for the oxygen and 4. That means 44U, I have got it. This is what the question is requiring. So we get a molecular mass of 44U. Even if you do not know the ozonolysis reaction, you get your answer just by hit and trial method. That is what? Here R will be methyl and we get our answer. But let us just perform the reaction here in order to have an idea. So these are the reagents used in the reaction, and what do we get? This is how the ozonide is formed, that is the intermediate, and that is how it is going to break into 2 moles of ethanol. So that is what the entire reaction is. I hope everybody is very clear to it. So what is this? This is but-2-ene is the answer. 2-butene is the answer. C is the answer. I hope everybody is clear with the concept. Let us just move on to the next question. What does it say? 2-methylbutane on reacting with bromine in the presence of sunlight gives mainly. So let us just have the compound first. 2-methylbutane, that means this is what we are requiring. This is the compound which is given in the question. So it is 2-methylbutane. We have got the compound, right? I need to brominate it. Br2 in the presence of sunlight. So for these kind of free radical mechanism, it will follow. Free radical we all know. Remember having chain initiation, chain propagation and chain termination steps in the free radical mechanism, we all know. And also the free radicals, what is the stability of the free radical? Tertiary is always stable, then secondary, then primary. I am not talking about the carbocation, but I am talking about the free radicals over here, just mind it. So that is for the free radical stability. So out of all, which type of carbons are present over here? So it is a primary carbon. It is what? It is a tertiary carbon. Again a primary. It is a secondary carbon. And this is what? This is again a primary. So in order to have a stable product where the bromine needs to be attached onto a very stable free radical. So where is the stable free radical formed? It is formed always on the tertiary carbon as per the stability order. So it will be something like this. And that is how the bond is breaking, and we get as this as the free radical. This is the free radical that we are getting, and the bromine also breaks into a free radical. That is how the breaking is. This is homolytic fission. So we get 2 bromine free radicals. One of them will get attached over here and we get our product. So that is how the reaction is happening. I hope everybody is actually performing the reaction along with me. So in order to have a good practice of it, you just need to simultaneously do it with me. So let us just have the options I have got, let us just name it as well, because in the options we have got the names. So here it would be 1, 2, 3, 4. It is 2-bromo and 2-methyl. So 2-bromo, 2-methyl butane, that is the answer. 2-bromo, 2-methyl. That means I have got the answer as C here. I hope everybody has got the answer right. Now let's move on to the next question. What do we have here? In the next question, the hydrocarbon which can react with sodium in the liquid ammonia. So you have got sodium in liquid ammonia, that is the reaction that I need to perform. I have got a hydrocarbon and I need to have a reaction Na in the liquid ammonia. This is what kind of a reaction? This is a reduction reaction and it is known as what? This is known as Birch reduction. So that is Birch reduction that we have. And just remember this very carefully, always this reagent always acts on terminal alkynes. So it always reacts with terminal, that means the triple bond must be on the last carbon first, that is for the terminal, and it must be an alkyne, not an alkene. So that is the condition for this reagent. So if you observe here, which is the terminal alkyne present? Terminal means on to the last carbon there should be a triple bond. This is not, because here the triple bond is somewhere in the middle. If you see, this is, but again here this is not an option. This is not an option because this is alkene, not alkyne. So here let us just try to perform the reaction. We have got the answer here, that is B, and the reaction would be what happens? Na in the presence of liquid ammonia we get it as CH3, CH2, C, Na positive, C negative, Na positive. That is what we are getting in this reaction. So I hope you are clear with the concept. You need to remember this very specifically, that this reagent, the Birch reduction, always gives reaction with terminal alkynes. So remember that. So let's just move on to the second last question. What do we have? The reaction of toluene with Cl2 in the presence of FeCl3 gives predominantly. So it's a pretty simple reaction. I need to have toluene with a reaction with Cl2 in the presence of FeCl3. So I have got toluene. I need to react it with Cl2 in the presence of FeCl3. What is this kind of a reaction? This is nothing but electrophilic substitution. So that is electrophilic substitution. That means I need to generate the electrophile. So what will be the mechanism? It will be this FeCl3 is electron deficient. It fetches out one chlorine. It takes one chlorine, and what do we get? We get FeCl4 negative, that is a complex which is formed, plus Cl positive. So this is the electrophile that is attacking now on the benzene ring. But where on the benzene ring? So if you see, this very particular group is showing plus it is showing plus I effect, also hyperconjugation effect. So all those kinds of effects it is showing. That means it is a donating group. So that is what? Donating group. So due to this donation capability, it is activating the benzene ring. So the benzene ring is getting activated on ortho positions and the para positions. So these positions, ortho and para, are actually having high electron density. So it will attract Cl positive towards the ortho and para positions. So here let us just analyze the options. It will give what? Benzoyl chloride, benzyl chloride, ortho and para chlorotoluene and metachlorotoluene. So it is ortho and para chlorotoluene. So we get two products over here. What two products we get? So I am just drawing it over here. First I attach the chlorine onto the ortho, plus again I attach the chlorine onto the para. So these are the two products that we are getting here, and this product is minor due to the symmetry issues, and this is a major product, that means having the highest possible amount formed. So this is in a major quantity due to symmetry. As you can see, this is symmetric and this is slightly non-symmetric. So that is what is going on in this reaction. I hope everybody has got it. C is the answer. Let's move on to the next. So what does the next question say? That will be the last one. Which one of the following has the minimum boiling point? So what is the boiling point concept? So as per the boiling point, what is the boiling point concept? More the branched, so more branching, less boiling point. Due to what? Due to less van der Waals forces of attraction, less van der Waals forces. So that is the concept. And if the compound is linear chain, it will have more boiling point, because now in between the molecules there will be higher attraction, so and more surface area as well. So it will be more van der Waals forces of attraction. So let us just analyze the options. N-butane, that means straight chain. 1-butyne, butene, and isobutene. That is the isobutene. So if you see, what is the question saying? Which one of the following has the minimum boiling point? Which will be having the minimum boiling point? The one having the highest branching. So out of 4, we can see here that these are linear chains having no branches. So these are having no branches. That means it will be having higher forces of attraction. That means what? That means having higher boiling point. But here if you can see, there is branching. That means lesser surface area and lesser boiling point due to lesser van der Waals forces of attraction. So that is the answer to this question. Isobutene is the answer. I hope everybody has followed the questions very well, and I hope you have got the concepts along with a proper clarity. So we will be discussing the advanced type questions of hydrocarbons in the next session. Till then, just revise what we have done, revise all the questions thoroughly. While writing them, you do not need to just go through them, just try to practice the questions. So I'll be back in the next session. Till then, have a good day.